Hi, I'm Sarah LaSelva with National Instruments, and I'm here at the Brooklyn 6G Summit demonstrating our AI benchmarking testbed. So with AI, we, as a test and measurement company, we're trying to understand how do you have deterministic, measurable comparisons between systems that use AI and systems that don't. So what we've done, and what we're showing here today, is we've actually built up a 5G NR compliant wireless system. So we're running a G-Node B on the left side of the table and a UE on the right side, and it's all based using OpenAir Interface's 5G NR software. In the middle we have USRPs acting as our RF front end, and then we've cabled everything up through a VST, which is running as a channel emulator. And so what we're showing in our testbed today is we're actually running two different versions of our base station. The first version is just 5G NR compliant as it is, doing the traditional processing. The second version is we've taken out some of the receive chain and replaced it with a machine learning algorithm, DeepRX, which is something that's been open sourced from Nokia, to do some neural receiver processing. And so the neural receiver is actually running on a GPU back here inside of the server. And then what we're doing with our testbed is we're running two different versions. So we're running that traditional version, and then we're running the AI version so that we have a comparison between the two, and we can actually look at the performance differences. And what we're seeing here, and it'll start populating more as it keeps running, when we're looking at a lower modulation at a 16 QAM, we get about 3 dB better performance using the AI model. But when we move up to a higher order of modulation at 64 QAM, the performance difference is that we're getting is only about 1.5 dB, give or take, on the exact settings. So this has been helpful for us to understand some of the implications of just the way we trained the model and the different performance that we're getting in an actual real-time system. That's one of the other important things to mention here, and one of the learnings that we had as we did this. We were able to train our model when it was just simulation. We could train it with as much data as we want, make it very large and very robust performance. But once we actually started considering what we needed to do to meet timing constraints in a 5G NR system, we had to start making the models smaller, which meant that we couldn't have as robust of training for all of the different corner cases. So we're not AI experts, and our goal wasn't to develop the best model possible, but really to create a testbed where we could actually start doing some of this benchmarking and learning a bit more about the AI performance. So hope you enjoyed our demo, and if you have more questions or want to learn more, check out ni.com. Thanks.